Hello and welcome to Mr. Thompson's Math Tutorials. Today we're going to be looking at factoring, and I want to start off by kind of reminding you of something that you should already know how to do. So I've got 18 over 27. This is a fraction, and one of the things that I want to do is simplify this fraction. I want to make it smaller. So I want to make it into its lowest terms. So what I'm going to do is I'm going to be dividing by the GCF, which is the greatest common factor. Okay, so first thing I have to do is find the greatest common factor of 18 and 27. Now remember, factors are numbers that when multiplied by another number will give you, for instance, 18. So, and they always come in pairs. So I always start with 1 and 18. That's a factor pair because 1 times 18 is equal to 18. I also know that 2 and 9 are a factor pair because 2 times 9 is 18. Another factor pair that I have are 3 and 6 because 3 times 6 is 18. And you kind of get this nice little rainbow effect, and I often call this, factor rainbows. But that is all the factors of 18. Okay, let's do the same thing with 27. So all the factors of 27, I've got 1 and 27. Now 27 is not divisible by 2, but it is divisible by 3. So 3 and 9. It's not divisible by 4. It's not divisible by 5. It's not divisible by 6 or 7 or 8. So I meet myself at 9, and I can see, once again, this is my upside down factor rainbow, but 3 times 9 is 27, and 1 times 27 is 27. So then I look for the greatest common. Common means the same in both lists. Now I have 1 and 1, but 1 is kind of a useless number. Not really, but it can be. 3 and 3 are common, and then I have 9 and 9. But 9 is my greatest common factor. So what I'm going to do is I'm going to actually divide top and bottom by 9. But what I want you to understand is that this can also, you can see that why you're dividing by 9 and 9 if you can decompose these numbers. So if I take 18, 18 is actually equal to 9 times 2. And 27 is actually equal to 9 times 3. What I've done is decomposed. And I'm going to show you why dividing by 9, dividing top and bottom by 9 actually works. So now if I solve this, or if I decompose it just a little bit more, I can see that I can pull apart 9, the 9's from there, and the 2 and the 3. So I have 9 over 9 times 2 over 3. Now this is completely and totally legal because when I multiply fractions, remember I multiply across the top and multiply across the bottom. So 2 times 9 is equal to 18, and 9 times 3 is equal to 27. But 9 over 9 is actually equal to 1. You can see that this is a big fat 1. So that's actually equal to 1. And 1 times a number is equal to whatever that number is. So in this case, 1 times 2/3 is equal to 2/3. Now this is why dividing top and bottom by 9 works. Because basically what I'm doing is dividing by the greatest common factor. Okay, and in this case I'm going to end up with 2/3. Okay, so this is something that you already have done. Now, what do I do when I have an x in there? So you can see here on this one, I'm looking at it and I've got 18x and 27x. Well, I can do the same sort of decomposition. I've got 9 times 2 times x. This is equal to 18x because 9 times 2 is 18 and 18 times x is 18x. And I can do the same thing here where I have 9 times 3 times x. Okay, so I've decomposed this number. I have 9 over 9 times 2 over 3 times x over x. Okay, and basically you can see I've got two ones now. I've got 9 over 9, which is 1 in disguise, and I've got x over x, which is also 1 in disguise. So 1 times a number is essentially 1. So this is still 2/3. And we can look at this when we're looking at this particular thing. We can see that I would be dividing top and bottom by 9x. So I divide top and bottom by 9x, and this is going to simply leave me with 2/3. But the reason it works is all of this over here. Okay, let's look at another example. So on this particular example, I've got 18x squared and 27x. So I'm going to decompose the number once again. This is 9 times 2 times x times x. X squared is equal to x times x. And that's over 9 times 3 times x. I'm going to rewrite this. I'm also going to add a 1 here. Just it'll make my life easier. Anything I multiply times 1 becomes whatever it is. So this is still equal to 27 because 9 times 3 is 27, times x is 27x, times 1 is 27x. But it'll make it so that this has something to be over when I make them into fractions. So I have 9 over 9 times 2 over 3 times x over x times x over 1. And I can see once again that this is a big 1. This is 1 in disguise, but so is this. Now this is not 1 in disguise because it doesn't have the same thing over the same thing. It doesn't have x over x or 9 over 9. It has x over 1. Okay? Now, these essentially cancel out and go away. But that's going to leave me with 2/3 times x over 1, which is 2x over 3, because 2 times x is 2x, and 3 times 1 is 3. So I can see that this is actually equal to 2x over 3, but what I'm doing also is I'm dividing top and bottom once again by 9x. I'm looking for that commonality between these two numbers to divide by, to bring that out. Okay? Now, this is a little different look, but if I look at this particular thing, and if I remember back to the distributive property, what I want to do is undistribute something out of this. So I want to look for that greatest common factor. Now, we just saw that the greatest common factor of both of these numbers is 9x. So if I think to myself, okay, what is the greatest common factor of these two numbers? I'm going to start with the whole numbers. Okay, the coefficients actually. 18 is actually called a coefficient. 27 is called a coefficient. In this expression, I have 18 and 27 as coefficients. And then I've got my variables. This is a x times x, which is x squared. And this is just simply an x. Okay, so I'm looking for the greatest common factor of my coefficients and then my variables. Okay, and basically what I want to look for is commonality. What do they have the same in both variables, and what's the greatest common factor in both coefficients? So I can see that I have an x in this variable and I have two x's here, but I have at least one. So that's what I'm going to bring out. Basically what I want to do is kind of do what we did here. I'm going to divide. Here I divided top and bottom by 9x, right? I divided top and bottom by 9x. I'm going to do the same thing here, but instead of just canceling them out, I'm going to put that 9x on the outside. So 9x times what is equal to 18x squared? Well, if I think of what 18x squared is decomposed, it's 9 times 2 times x times x. If I'm taking this out, sorry, I'm not taking that out. I apologize. If I'm, let me rewrite this in a different way. It's 9 times x times 2 times x. Okay, if I'm taking out this 9x, well, what does that leave me? Well, it leaves me with 2x. So that's 2x right here, plus. Okay, if I think of my 27, I have 9x, 9 times x is what I'm taking out, times 3. Okay, this is what 27x is equal to, and I'm taking this out. Okay, that's coming to the outside over here. Okay, well that leaves me inside just the 3 because that's gone, and all I have is the 3. Now this is what is factoring in algebra. I've basically factored out this 9x. It's kind of like setting these up and dividing top and bottom by the same thing. It's sort of like thinking of these as a fraction. What am I dividing top and bottom by? But you're not doing a fraction. And then instead of having your this as a fraction, this, if you remember our last example, this was, we ended up with 2x over 3. We ended up with this. We still end up with 2x over 3, or 2x and 3, but they're separated by a plus sign, not a slash. Okay, let's look at another example. Oh my goodness, 3 of these. But again, what I want to do is I want to think to myself, what is the greatest common factor? And then what common variable do all 3 have? And that's what I'm going to pull out. And then I'm going to think of my decomposition and basically solve from there. So if I think of my greatest common factor, well, I've got 6, 3, and 12. So what is my greatest common factor? Well, I'll do my factor list. 1 and 6, 2 and 3. Okay, and then I have 1 and 3, and I have 1 and 12, 2 and 6, and 3 and 4. Okay, so the greatest common factor here, I've got 1s in all of them, but we don't want 1s. There's not a 2 in 3, but there's a 3. So this is my greatest common factor, and so that's what I'm going to pull out of each number. Now, here, my factors of my x's, I can think to myself, well, this has 1x, this has 2 x's, there's 1x here, there's 2 x's here, and there's 3 x's here. Well, what do they all have? Well, they all at least have 1 x. So that's something that I'm going to pull out of all 3 of these. So here we go. Let me just erase this. Give me a little room. Okay. So I know that I'm going to pull out 3x from each one of these in here, each one of these terms within my expression. So I have to think to myself, 6x is actually equal to, so if I rewrite 6x and decompose it, I can see that it's equal to 3 times x times 2. So that means that I'm taking out the 3x, okay, and that leaves me with a 2. 3x squared is equal to 3 times x, but I'm taking out this 3x, right? So that leaves me with an x. Okay, I'm going to do the last thing for 12x cubed here. So 12x cubed is going to be 3 times x times 4 times x times x. Now I've also used the associative property by moving some things around, and I did that without showing you. But this is still equal to 12x because 3 times 4 is 12, and then x times x times x is 3x cubed. Okay, but I'm taking out this 3x, and that leaves me with 4x squared. So this would be 4x squared. Okay, and now this has been factored. All right, well, let's look at another example. Okay, this time there'll be 2 variables in there, but same idea. I want to look for commonality in the variables and the greatest common factor within the coefficients. So first I need to find the greatest common factor within the coefficients. So that's 4, 14, and 20. Well, 4 has 1 and 4 as factors, and then 2, because 2 times 2 is 4. Okay, 14 has 1 and 14, and 2 and 7. And 20 has 1 and 20, 2 and 10, 3 no, 4 yes, 4 and 5. Okay, so those are all the factors, and then I'm just looking for the greatest common factor, and I can see that in this, there's no 4 in my factors of 14, so the greatest common factor is in fact 2. So that's what I'm going to pull out of each coefficient, and then I need to look for commonality within my now there's already a 2 out of here too, so that's going to have to be multiplied times 2, and then times whatever the common in the variables. So I know that y is actually equal to x times y, and this is equal to x times y, and this is equal to x times y. Okay, so what do I see that's common in all of them? Well, I have an xy here. Oh, I have an xy there. Oh, and I have an xy here. So I'm going to be multiplying times x times y. That's what's coming out to this is coming out of all of this. In fact, I'm going to change the color of this first two because that was there originally. But I'm taking out this 2xy from each one of these. Okay, so let's see. 4xy is equal to 2 times x times y times 2. And again, I'm taking this out, which leaves me with a 2 inside. Okay, and then I'm actually in this case I'm subtracting. I have a minus. So let's look at 14xy squared. So I have 14xy squared. Well, this is equal to 2 times x times y times 7 times y. I'm taking this out, so it disappears, and I'm left with 7y. So 7y. Okay, let's look at the last term. So I've got 20x squared y. Well, I know that this is equal to 2 times x times y. That's what I'm taking out. And then what's left over? Well, there's a 10 because 2 times 10 is 20. And then I have another x because I had an x squared. But this is going away, which leaves me with my 10x. So plus 10x. Okay, now I'm just going to put this all back together. I'm going to recompose it. Okay, so I'm composing this right here because I have to multiply this 2 times 2, which is 4xy times 2 times 7y plus 10x, I'm sorry. Okay, and that is fully factored. Thank you for watching.